In this problem, we're given the function h of t, which turns out is the height of a ball measured in feet above the ground that was thrown from a roof, and the input variable t is the time in seconds after it was thrown. We are to interpret the notation h of 2 equals 96 in the context of the problem. Notice that the input variable was t and they replaced t with 2. This tells me that 2 is a time value and that it's in seconds. So that means at 2 seconds, the output variable h of t, which was the height, is 96. So that means at 2 seconds, the height of the ball was 96 feet above the ground. Now on the second part, the question is much more involved. Instead of giving me the t value, they're asking me for the t value. Find the values of t such that h of t, the output here, is 24. Since my output is 24 feet above the ground, this means I'm supposed to find the time at which the ball is 24 feet above the ground. And if I do that, I will have done both the solving of the question and interpreting the result. So the question is, at what time, when, is the ball 24 feet above the ground? And I'm given the output variable h of t is 24. So if I replace h of t with 24 and copy the rest of the equation, I can solve this two ways. The first way I'm going to solve it is the quadratic formula that says if you have something of the form ax squared plus bx plus c, but it must be equal to 0, you can solve this using the quadratic formula. Notice my equation is of this form. I have some number times a quadratic term plus some number times a linear plus a constant, but I do need to get it equal to 0, and if I did that, my solutions, normally you'd say x, but in my case t, would be found by taking the opposite of b, in one case adding, in one case subtracting, the square root of b squared minus 4ac all divided by 2a. Make sure that the division bar goes all the way across here. In fact, my a will be negative 16, b will be 40, but my c value is not 80 because to use the quadratic formula, one side of the equation has to be 0. So to accomplish that, I'm simply going to subtract 24 on both sides, and that will give me 0 over here. The 80 minus 24, that is 56. Now that I have that, I can identify the number in front of the squared term is negative 16. That would be my a. And the number in front of the linear coefficient there is 40. That would be my b. And then my constant term at the end is 56. So I need only plug those numbers in and perhaps use my calculator to evaluate it. So if b is 40, the opposite of 40 would be negative 40. And then in one case I'm going to add, in the other case I'm going to subtract. b is 40, so 40 squared, minus 4 times a, which was negative 16. And c is 56. And then remember that all of that, this all needs to be done first. The last thing that will be done is you divide by whatever 2 times a is, and a is negative 16. So I'm going to be doing this on my calculator, and I happen to have my calculator in classic mode. So if you have your calculator in the math print mode, and you know what that means, then some of the parentheses I'll be using here won't be necessary. So let me start by doing a negative, not a subtract. It's just a negative 40. I'm going to start by doing the plus case. And then square root is second, and then the x squared key, you'll get the square root there. Now in classic mode, you get a left parenthesis there. In math print mode, you won't. This radical, you just keep moving wider and wider and wider to fit everything in that you type. But since I'm in classic mode instead of math print mode, I'm going to need a right parenthesis when I'm done here. So 40 is being squared. I have subtract. And then I have 4 times a, which is negative 16. And then I'm also multiplying by 56, so put that in parentheses. And then remember that left parenthesis here, and if I put a right parenthesis here, that will match, and it'll tell the calculator that all of this is to be under the radical, meaning all of this is the radicand. Now, to avoid more parentheses, I'm just going to press enter, but if you wanted to do it all in one command line, you would need a left parenthesis here, a right parenthesis there to let the calculator know that all of that is done first before you divide by the 2a. But I'm going to do it in steps, and I'm going to take this part and say that that's 32. Now I haven't divided by 2 times a. If you want, 2 times negative 16 is negative 32, and you can simply type that. I'll go back and delete it to show you the alternative. Now notice when I hit the division key that I didn't have to tell it what I was dividing from. It just assumed, since I didn't type a number, that it meant the previous answer that I got. So I'm going to show you the wrong way to do it. If you type in 2 times negative 16, this will be the wrong way, because on the calculator, when you hit the division key, the default is to only divide by the first number, meaning that the 2 is going to be the denominator, but the negative 16 will be put into the numerator, and we don't want it there. So I'm going to back up and do what I was supposed to, and let me insert some parentheses here. In fact, I can insert by hitting second delete. So left parenthesis here, right parenthesis there. Let me press enter, and by putting parentheses again, the negative 16 was thought of as being in the denominator, so you get exactly what you thought you should get. 32 divided by negative 32 is negative 1. Now in my story, that's a t value, and it's in seconds. So one of my solutions was exactly t equals negative 1 second. And since it's negative, it means that's 1 second before the ball was launched. I'm not even concerned about what happened before the ball was thrown from the roof, so I'm going to throw that answer out and look for the other. So my other solution would be exactly this. The newer calculators, you can just up arrow over there and press enter, and it'll copy it. If you don't have a newer calculator, press second enter to have the last thing displayed on your screen typed again. If you press second enter again, it'll display the thing before that, and so on. So I'm going to left arrow over because my next problem is exactly the same, except for where I had a plus right there. I went a little bit too far. Where I had the plus right there, I want to change to a subtract. Notice that this needs to be a negative here, and this needs to be a subtract, and they do look different on the calculator. You can press second enter a couple of times, and it'll retype this step that says take the previous answer and divide it by the quantity 2 times negative 16. You will get 3.5. Remember, that's a t value. So t is 3.5 and t is time in seconds. So this is the time at which the ball is 24 feet above the ground. So I have done both things asked. I found the values of t. One was negative 1, one was 3.5, such that h of t would be 24. These are the time values that you get out 24. I didn't care about the first one because it didn't make sense in my story, but I do care about this one. The height above the ground will be 24 feet, and that'll happen at 3.5 seconds. And that's exactly what they want you to say when they say to interpret your results in the context of the problem. Let me make sure that I write that the height is 24 feet above the ground. So at 3.5 seconds, the ball is 24 feet, not above the roof, above the ground. Now, I said that this is one of 2 ways that the problem can be done. The other is to use graphing technology. So back on my calculator, if I had gone to my y equals, I could have typed in the equation for the height, which was negative 16. The calculator uses the letter x for its input always, so you just have to know that when my calculator uses x, we think of it as t for time. And I'm going to type the problem in, and you can see on your screen what key presses I'm making. And as a second equation, so press enter or the down arrow, I'm going to type in the desired height. The desired height was 24 feet. So when I graph this, I'm going to get a parabola, and since the leading coefficient is negative, it's going to be open downward, so it's going to look like an upside down U. As a second graph in red, I'm going to get a horizontal line, y equals 24. Now, look at my window here. You would want to change your y max to at least 24, because you're going to get a horizontal line through 24 to see the desired height. If you wanted to see higher, you might notice that the ball starts at a height of 80. Now I got that by just mentally plugging in t equals 0 to see how high the ball was at time 0. At time 0, all of this would simplify down to be 0, and you'd get a height of 80. So if you put it at 80, that would give you the initial height. But the whole idea is that the ball is being thrown up even higher. So if I went to 100, probably I wouldn't see the entire graph right here. So if you wanted to see the high point of the graph, you could go even higher. But for the purposes of this problem, I need only see the intersections. I want to know when the parabola, the blue graph, takes on an output of 24. And you could think of that red line as a reference line because all of the outputs on that line are 24. I need only run my intersect feature now, which was second calc. I want to use my intersect feature number 5. It asks me, is this the first curve? And I'm going to say yes. Is the red line my second curve, y equals 24? I say yes, that's the second one. And the guess, because the calculator can only find one at a time, will tell the calculator which one you want to find first. If I guess over here, I'm going to get a negative solution. So suppose I hadn't done the quadratic formula yet, I still would know that I don't want that solution because here's t equals 0, and this solution would have a negative input value, and that would mean a negative time value. And I don't want to consider what happens at negative time values because that's what happened before the ball was thrown. So to make a long story short, when it says guess, right arrow over to the rightmost intersection. You can be a bad guesser. To prove that, I'm going to trace a little bit too far. It's just going to find the one that's closest. So press enter, look for the word intersection. Notice that even if I hadn't done the quadratic formula, I could still ascertain that the ball would be 24 feet above the ground after 3.5 seconds.